This video explains one-sided limits using graph and continuity at a point. One-sided limits. One-sided limits are left limit, limit f of x as x approaches c from the left. So the negative x superscript x tells you that you approach c from the left, and also means x is less than c, always. To find the left limit graphically, you approach c from the left. And when you are close to c on the x-axis, the height of the graph, or we say y value, on the graph is the left limit. Right limit is expressed like this: limit x approaches c with a plus superscript f of x. To find the right limit graphically, you approach c from the right. And when you are close to c on the x-axis, the height of the graph y value is the right limit. Definition of continuity at a point. A function f of x is continuous at x equal to c if all of the following conditions are satisfied. Number one, f of x at x equal to c is defined. That is, f of c is a real number. Mean function value evaluated at c is a real number. Number two, limit of f of x as x approaches c exists. That is, a limit of f of x as x approaches c from the left exists. A limit of f of x as x approaches c from the right exists. And limit of f of x as x approaches c from the left equals the limit of f of x as x approaches c from the right. Third condition, function value at c is equal to limit of f of x as x approaches c. If any of the above conditions is not satisfied at x equals to c, then the function is discontinuous. You can say not continuous or say discontinuous at x equal to c. Here's an example. Use the graph to determine each limit and discuss the continuity of the function. So first we're going to find the right limit of f of x as x approaches c. So again, let's find the right limit of f of x as x approaches c. So first you look at what is c. Well, c in this graph is here negative 2. So here's a negative 2. So we have to approach from the right to this one. Okay. So just imagine that there are two flies and they are connected with a string. So when this fly moves on this line, this fly moves along this one, pushes to this one. So as this is close to negative 2, this fly close to what? This position. And this point, on this point is has coordinates negative 2 and positive 2. So when x is close to negative 2, the y, the height, is close to 2, meaning approximately 2. So you will say the limit of f of x as x approaches negative 2 from the right is equal to 2. Okay, so now we're going to find the left limit as x approaches c from the left. Now again, c is negative 2, so we're going to find the limit of f of x as x approaches negative 2 from the left. So this side is the left, so we're going to go this way. So assume these two flies are connected with a string, and they are moving. One is moving up along the curve, this is moving along the x-axis. So as this fly gets close to this one, this fly will get close to this height, this point. So when x is close to -2, this fly is this much at this much height, which is 2. So we will say limit of fx as x approaches -2 from the left is equal to 2. So let's find the limit of fx as x approaches c, where c is -2. From part A and from part B, we found the limit of f of x as x approaches c from the right was 2, and the limit of f of x as x approaches c from the left is 2. Both are the same, so by definition of limit, limit exists, and the limit of f of x as x approaches c is equal to 2. So now we're going to check continuity of f of x at x equal to -2. From part C, we found that the limit of f of x as x approaches -2 is 2. Now let's find the value of the function at -2. So let's go locate this -2, you go up and say open circle, so you pass through that one and you hit a solid circle. So at this, the coordinates of the points are -2 and 3, so the y value is 3, or you can say function value is 3. So, so we conclude at -2, f of -2 is 3. Okay, now what we have is the limit of f(x) as x approaches -2 is 2, and function value evaluated at -2, 3, so they are not equal. And this is one of the conditions. Then the limit of the function should be equal to the value of the function. Then the function is continuous. Since they are different, they are not the same, so we'll say f of x is discontinuous or not continuous at x equal to -2.